Alright guys, welcome for another exciting installment.
Why do you say installment?
Oh, well because
What is installment?
it's like several installments. Alright guys, so here's quiz 19, optimization. So the key on this one guys is just to make a model, and then from that model you're going to be taking a derivative. So let's get started. A rectangular garden, 200 square feet in area. So this is called your restriction. It's a rectangular garden, and you max area is 200, or your area is 200. So 200 is to be fenced off against rodents. Find the dimensions that will require the least amount of fencing if one of the sides of the garden is already protected by a barn. All right, so here's the barn. I'm gonna take it over there. So this is X, this is Y, this is Y, and what I'm trying to maximize is the amount of fencing, or minimize the amount of fencing. So I know that my area is going to be X times Y, and I know that equals 200, and the amount of fencing is just X plus 2Y, and that is what I'm trying to minimize. So that's what I'm going to take a derivative of. I'm going to replace the y with, let's see, divide by x, y equals 200 over x. So I'm going to replace that y with that. So fencing equals x plus 2 times 200 over x. So you get x plus 400 over x. Now I'm going to take a derivative of that. If you want to rewrite it, guys, you can rewrite it as x plus 400 x to the negative 1. So here we go. Derivative f prime 1 of x is equal to 1 minus 400 over x squared. Set this equal to 0. Because this is a restraint or a closed region, you know that this one critical value has to be your min. So I'm going to move this to the right. So 1 equals 400 over x squared times x squared times x squared. X squared equals 400, square root. And I want to say that x equals 20. As soon as you know that x equals 20, I can find y by simply plugging it right, where are you? Right here. So y, if you do 200 divided by 20, you get 10. So there it is, guys. Those are my dimensions. 20 by 10. Yay. I hope you guys like that one. Find the largest possible area for a rectangle with a base on the x-axis and upper vertices on this curve. So that curve looks like this, guys. It's just like our example, really. It might be the same one. I'm not sure. I don't remember. I'm trying to make the vertex right on the y-axis. I didn't succeed. That's okay, though, because I've never been really good at drawing. I did not score very well in my university drawing course. So here is my rectangle. And the distance from the origin to this guy right there, that is an x. So then that means my total width here is 2x. And then that height is dictated by that y value. And that y value is dictated by 6 minus x squared. So my area is equal to 2x times y, which is 6 minus x squared. This is what I'm trying to maximize. So this is what I'm going to take a derivative of. Distribute the 2x. So area equals 12x minus 2x cubed. And here we go. A prime equals 12 minus 6x squared. I'm going to equal that to 0 to get my critical number. Move the 6x squared to the right, but I like to write it on the left-hand side. 6x squared equals 12. Divide by 6, so you get x squared equals 2. And then we're going to take the square root. So x equals the square root of 2. All right. So now that I have that, it says find the largest possible area of the rectangle was based on the upper vertices in the curve. All right, so they actually want the area. Find the largest possible area. So now that we got this, I'm just going to plug that number in here and in here. So my area is equal to 2 times the square root of 2 times 6 minus, well, x squared is 2. So 6 minus 2. So 2 square root of 2 times 4, and then 4 times 2 is 8. So my maximum area is 8 square root of 2. And you know that it's a maximum, guys, because you have a closed region. So any critical number you get is going to be a max. All right, let's go to the next question. Of all the rectangles in area 144, find the dimensions of the one with the smallest perimeter. Well, if you know geometry, you know that the smallest will be a square, but let's pretend we don't know geometry. So I have a rectangle. So let's draw a rectangle. And the area is 144. Here's x, here's y. So my area is x times y is 144. That's a restrictive equation. And it wants the smallest perimeter. So my perimeter is 2x plus 2y. So this is what I want to maximize. So this is what I'm going to take a derivative of. So I use this guy. xy equals 144. Divide by x. Divide by x. Y equals 144 over x. I'm going to plug that in there. Perimeter equals 2x plus 2 times 144 over x. When I multiply those two dudes, you get 288 over x. And I'm going to take a derivative of this. So I'm going to write 2x plus 288, x to the negative 1. All right, p prime. Derivative of 2x is 2. And the derivative of 288 minus 288, x to the negative 2. I'm going to equal that to 0. So here we go. 2 equals 288 over x squared times x squared times x squared. 2x squared equals 288. Divide by 2, divide by 2. X equals 144, or x squared equals 144. Then square root. And then x equals 12, because the square root of 144 is 12. So if x is 12, y has to be, well, you come back over here. 144 divided by 12 is 12 again. So there it is. So y has to be 12, guys. Okay, let me take this real quick. Here we go, guys. Let's go to the next one. Of all the rectangles with a perimeter of 168, find the dimensions of the one with the largest area. Okay, so this one is different. So I have a rectangle, and then the perimeter is 168. So x, y, y, x, and then want the largest area. All right, so my perimeter, I'm going to say P equals 2x plus 2y, which equals 168. That's your restrictive equation. My area is x times y. I'm going to solve for y here. So get it in terms of x. So let's see, 2y equals 168 minus 2x. Divide by 2, divide by 2, divide by 2. Y equals, let's see, 168 divided by 2 is 84 minus x. So I'm going to plug that in. Area equals x times 84 minus x. So area equals 84x minus x squared. So here we go. That's what I want to maximize. So a prime equals 84 minus 2x. And then I'm going to equal that to 0. So 2x equals 84. Divide by 2, divide by 2. X equals 42. So as soon as I know what x is, I can solve for y by plugging it in right there. So 84 minus 42 happens to be 42 again. So there it is. Yay. Here we go, guys. Next one. The rectangular playground is to be fenced off and divided into two parts by a fence parallel to one side of the playground. 240 feet of fencing is used. Find the dimensions of the playground that will enclose the greatest total area. Okay, let me see if I understood that. I have a rectangular playground. The rectangular playground is to be fenced off and divided into two parts by a fence parallel to one side of the playground. Okay, there it is. You can cut it the other way too. 240 feet of fencing is used. Find the dimension of the playground that will enclose the greatest total area. Okay, so I have x, x, and then I have y, y, y. So let's see. Fencing is 2x plus 3y, and all that equals 240 feet. I'm trying to maximize the area. The area is still x times y. So I'm going to solve for y. So here we go. 240 3y equals 240 minus 2x divided by 3, divided by 3, divided by 3. So I get y equals 240 divided by 3 is 80. 80 minus 2/3 of x. Okay, I'm going to plug that in there. So I'm going to write it right here, guys, because I got some space. Area equals x times 80 minus 2/3 x. Distribute, so I have 80x minus 2/3 x squared, and that's what I want to take a derivative of because that's what I want to maximize. So the derivative is 80 minus 4 over 3x, again, equal that to 0 to find my critical point. So 4/3 x equals 80, multiplied by the reciprocal. So 80 times 3, and then that number divided by 4, and you get 60. Now that I know that x is 60, I can solve for y by plugging it right there. So 80, so y equals 80 minus, I'll just put the answer here, 80 minus 2/3 of 60, and I get 2/3 of 60, and I get 40. So there it is, guys. Sorry, I'm just doing something real quick. And here you go. And there it is. That's it. Pretty simple, guys. I didn't think it was anything crazy. Alright, guys, here we go. On this one here, we have to create a system of equations. Really, in all of them, it's really you are doing system of equations. So you already know that the value is 32 when x is 16. So first, let's do that. So 32 equals, and the square root of 16 is 4. So I'm going to say a divided by 4 plus, and then this one is 4b. All right, so now we're going to take the derivative. So before I do that, guys, let's rewrite it. So a x to the negative half plus b x to the half. So here we go. Y prime equals negative 1/2 a x to the negative 3/2 plus 1/2 b x to the negative half. So rewriting this, let's see. I know that I better equal 0 because I know that's a critical number. It's a minimum value. So negative a over 2. And I'm going to plug in the 16 already. 16 to the 3/2. So I'm going to plus 1b over 2 square root of 16. All right, the square root of 16 is 4. And 4 to the third, 4 times 4 times 4 is 64. So 64 times 2 is 128. I found the error the first time. Here we go. Negative 8 over 128 plus b over 2 times 4 is 8. So there we go. And now that still equals 0. So if I move this to the left, you have, I'm going to move it right here, guys. I have a over 128 equals b over 8. If you want to do cross multiply, you can. 8a equals 128b divided by 8 divided by 8. A equals 128 divided by 8 is 16. So a equals 16b. I'm going to plug this guy in for here. So I'm going to write it up here, guys. 32 equals... Everything all right over there, guys? Oh, sorry about that. 32 equals, let's see, A is 16b. 16 divided by 4 is 4, so 4b. And I don't see any errors so far. Let's see, 4b plus, and then that already says 4b there. So I have 32 equals 8b. Divide by 8, divide by 8. 32 divided by 8 is 4, so b equals 4. Once you have that, what b equals, you can get a really quick by just plugging it in right there. 16 times 4 is 64, so a is 64. Cool or not cool, guys? Cool. I think it's recording, guys. Yes. All right. Find the coordinates of the point on the curve that are closest to the origin. All right, this one's pretty basic. Divide everything by 2. So y equals 6 minus 1/2 x squared. And so that is just a parabola that opens downward with a vertex at 0, 6. So I want a point that is closest to the origin. So there it is, that's my distance there, and the origin is 0, 0. And that curve is some x comma, and the y value is 6 minus 1/2 x squared. Or you want to write it as x squared over 2, that's fine. All right, so next, here we go. I'm going to write, what am I going to write? I'm going to write, this is what I want to maximize or minimize, so this is what I'm going to take a derivative of. So let's see. The origin is 0, so x minus 0 squared plus, and then the y value is 6 minus 1/2 x squared minus 0 squared. So all I did was the distance formula, guys, which is this, change in x squared plus change in y squared. That's all I did. So when I square it, here's what I have. X squared, and then plus 6 times 6 is 36. 6 times 1/2 x squared is negative 3 x squared, and when I add them, I get a negative 6 x squared, and then half x squared times half x squared is going to be a positive x to the 4th over 4. All I did was FOIL, guys. So now, when I combine like terms, I'm going to put the highest degree first. X to the 4th over 4, and then 6x squared and x squared, that's going to be a minus 5x squared, and then plus 36. This is what I want to minimize, so this is what I'm going to take a derivative of. So the derivative of this guy is x cubed minus 10x, and I'm going to equal that to 0. So I'm going to factor out an x. So I have x squared minus 10. And so obviously x equals 0 is one answer, but that's not on the curve, so I want to point on the curve. But these points are, so x squared equals 10, so square root, x equals square root of 10. So that's my x value. You can also say x equals negative square root of 10. So plus minus. So then I start looking for that. Maybe I see 0, 6. No. Well, I guess 0, 6 is on the curve, but at x equals 0, you're way, well, at x equals 0, the distance is 6. See? This distance in blue, because that's at 0, 6. So the distance from the origin to here, that's just 6. So this is at square root of 10 is where you have your, the shortest distance. So to figure out your y value, guys, plug in square root of 10 in here. Square root of 10 squared is 10. Half of 10 is 5. 6 minus 5 is 1. So there it is, 1 and 1. So those are the points where your curve is closest to the origin. All right, this one here is actually in your notes. It's the exact same one on notes. It's the exact same one. So go to your notes, guys. Or just click on the YouTube video that we did a few days ago. It's uploaded. Here we go. Rectangle has one side on the x-axis, and the other per vertices, and it's e to the negative 4x squared. All right, so e to the negative 4x squared, if I remember correctly, is going to look something like this. Something like that, if I remember correctly, guys. So I want that. So let's see. The distance from here to here, that is some x value, and the distance, this is y value, and that depends on the curve, which is e to the negative 4x squared. All right, so my area is going to be 2x times e to the negative 4x squared. So here we go, guys, a prime. So I'm just going to put all this together, I guess. 2x e to the negative 4x squared. So a prime first times the derivative of the second, e to the negative 4x squared times the derivative of negative 4x squared, which is negative 8x. Oh. Negative 8x plus second e to the negative 4x squared times root of the first 2 equal that to 0. So I have a prime equal, let's see, negative 16x squared e to the negative 4x squared plus 2 e to the negative 4x squared equals 0. And then I'm going to factor out 2e to the negative 4x squared. And then 2 goes into 16 8 times. So I'm going to have negative 8x squared plus 1 equals 0. So this guy will never be 0. But negative 8x squared plus 1 will. So let's solve for when that's going to be 0. I'm going to come over here where there's some white space here, guys. So negative 8x squared plus 1. Negative 8x squared plus 1 equals 0. Negative 8x squared equals negative 1. So 8x squared equals 1. X squared equals a 1/8. Square root. X equals the square root of 1 is 1, but the square root of 8 is 2 square root of 2. And then I'll multiply by square root of 2 over square root of 2. X equals square root of 2 over 2 times 2 is 4. So there it is. This is the x value that will maximize my area, plus or minus. So I start looking for that. Square root of 2, 4. Nope. Maybe. I see that both of them are negative. Can't have both negative. One negative, one's positive. Nope. And then maybe. So it's between B and E. So what do you do to get the y value here? Well, you plug this into the original, which is e to the negative 4x squared. So I'm going to write, okay, y equals e to the negative 4. And the next squared was already 1/8, if you remember. So let's see. E to the negative 1/2. And there it is. Hope you like that one, guys. Okay, last one here. This one's going to take a while. The figure below shows a region that consists of a semicircle on top of a rectangle. Okay, I see that. Rectangle, semicircle. Give the value of x that maximizes the area of the region if the circumference, they should not use that word, they should use the word perimeter, of the region is 4. Okay, so a circumference of a circle is 2 pi r, but I don't have a whole circle, I have half a circle. So circumference of half a circle is just pi r. And then this is a rectangle. I have x and y. So here we go. My circumference is equal to pi r. The radius is going to be half x. R equals half x. So I'm going to say pi times half x. So that's going to give me the top half. And plus x plus 2y, and all that equals 4. Alright, so let's see. Pi x over 2 plus x plus 2y equals 4. So I'm going to solve for y here because I already know, let's see, area. So area is going to be pi r squared over 2 plus xy. So area equals pi, and my radius is x over 2, and then divided by 2 plus xy. So again, let's see, my area equals pi, let's see, pi, x times x is x squared, and then 2 times 2 is 4, and I'm dividing by 2 again, so it's going to be over 8, plus x times y, and I'm going to put what y is right now from right here. Let's see. 2y equals 4 minus x minus pi x over 2. I'm going to divide everything by 2. So y equals 4 divided by 2 is 2, minus x over 2, minus pi x over 4. So, and I could combine here, guys, but I'm not. I'm just going to leave it. 2 minus x over 2 minus pi x over 4. Alright, this is what I want to maximize. Let's see. The figure below gives the value x and maximize the area. Okay, this is what I want to maximize, so this is what I'm going to take a derivative of. So I'm going to first distribute here, guys. So pi x squared over 8 plus, let's see, plus 2x minus, that's x squared over 2 minus pi x squared over 4. I guess let's do common denominator for the pi x squares here, guys. Let's see, times 2 times 2, so 2, 8. So pi x squared minus 2 pi x squared is a negative pi. So area is negative pi x squared over 8 plus 2x minus x squared over 2. And I can probably combine the x squared over 2 if you really want to, but I don't want to. A prime equals, let's see, the derivative. Negative 2 pi x over 8. I'll reduce it a little bit, guys. Plus 2 minus 2x over 2. All right, let's reduce it. A prime equals 2 goes into 8 4 times. So negative pi x over 4 plus 2 minus x. And we're trying to solve for x, so I'm going to equal this to 0. So I'm going to move the x and pi over 4x, guys. So 2 equals x plus pi over 4x. I'm going to factor out an x. So 2 equals, there's my x factored out. And we're at 1 plus pi over 4. And I'm going to divide by 1 plus pi over 4. So 2 over 1 plus pi over 4 equals x. Now, look, you don't have it written that way. So I'm going to turn that 1 into 4 over 4. So here we go, guys. X equals 2 over 4 over 4 plus pi over 4. So 2 over 4 plus pi over 4. Keep, change, flip. 4 times 2 is 8. So 8 over 4 plus pi. And we look for that answer. If you can do that, guys, and you understand it, then I think you're in really good shape. I hope you guys like this video. Thumbs up, please, hopefully. And I'll see you guys when I see you guys. All right, bye.